In this lecture, we take an example of sec to the power nx dx, integration of sec to the power nx dx under the limit 0 to pi by 4. So we have given the question, if in equal to integration of sec to the power nx dx under the limit 0 to pi by 4, then prove that in is equal to root 2 to the power n minus 2 upon n minus 1 plus n minus 2 upon n minus 1 into in minus 2. We have given that in is equal to integration of sec to the power nx dx under the limit 0 to pi by 4. So as we know that if you want to find out the reduction formula of sec to the power nx, we have to break this n to n minus 1, n minus 2 and 2. Then we have to prove that in equal to root 2 to the power n minus 2 upon n minus 1 plus n minus 2 upon n minus 1 into in minus 2. So from equation number 1, we have in is equal to integration of sec to the power nx under the limit 0 to pi by 4 with respect to x. So this can be broken into two parts, sec to the power n minus 2x into sec square x. And now we know that what is the integration of sec square x? It is nothing but 10x. So we can directly use the integration by part. First function, this is u and this is v. So we know that first function, integration of sec square x is equal to 10x under the limit 0 to pi by 4 minus derivative of sec to the power n minus 2 x is n minus 2 sec to the power n minus 3x, and again derivative of sec x is sec x into 10x, and then finally the integration of sec square x is nothing but 10x. If you put the limit over here, sec pi by 4, sec 45 is just opposite to 1045. 1045 is 1 upon root 2. So sec 45 is nothing but root 2 to the power n minus 2, and 10 pi by 4 is 1. And if you put the lower limit, sec 0 is 0, sec 0 is 1, and tan 0 is 0, so 1 into 0, minus n minus 2, this one n minus 2, in integration under the limit 0 to pi by 4, sec to the power n minus 3, and this is sec to the power 1, so it is n minus 2, and 10x into 10x is 10 square x. Now, if we again simplify it, so this is 2 to the power root 2 to the power n minus 2 minus n minus 2 integration of sec to the power n minus 2x into tan square x, which can be written as tan square x can be written as sec square x minus 1, which gives us root 2 to the power n minus 2 minus n minus 2. And now if we open the bracket, it is sec to the power n minus 2 plus 2 x minus sec square n minus 2x. So this minus 2 plus 2 will cancel, and we have root 2 to the power n minus 2 minus n minus 2 integration under the limit 0 to pi by 4 of sec to the power nx dx. This minus and minus will become plus n minus 2 integration of sec to the power n minus 2x under the limit 0 to pi by 4. Now we can write down, this is nothing but in, this is nothing but in minus 2, because here this is n and here n is replaced by n minus 2. Now we can transpose this minus I n minus 2 of in can be taken left hand side, and then we have in plus in n minus 2 into in, which is equal to root 2 to the power n minus 2 plus n minus 2 in minus 2. Now if we take this common as in, so 1 is remaining over here plus n minus 2 in, which is equal to root 2 to the power n minus 2 plus n minus 2 into in minus 2. And now it can be written as n minus 1 into in, which is equal to root 2 to the power n minus 2 plus n minus 2 times of in minus 2. So what is the in? We have to divide whole equation by n minus 1. Therefore, in is equal to root 2 to the power n minus 2 upon n minus 1 plus n minus 2 upon n minus 1 into in minus 2. And this is nothing but our result. This is desired result, hence proved. Thank you.